In this video, we're going to talk about solving systems of linear inequalities into variables, which means that our linear inequality will have two of them, and we're looking for the region where the shading overlaps. Again, let's remind us that the graph of the line and the appropriate shading for each inequality on the same coordinate plane is what we're looking for with our system of inequality. Also remember that the less than greater than will form a dashed line, and the less than or equal to and the greater than or equal to will form the solid line. The solution is where the section has overlapping shading, and is very useful to use different color pencils here if you're doing it by hand. We do use Desmos to help us, and Desmos does graph in different colors. So you're looking to see where those two colors overlap. Let's get started. So we have y is less than or equal to 2x plus 1, and we have y is greater than negative 2x plus 5. So in the first equation, y is less than or equal to 2x plus 1. The first type of question we're going to ask is the inequality a solid or a dashed line? And by looking at the less than or equal to sign, we know that this is going to produce a solid line. And since we're in slope-intercept form, we also know that the less than symbol means that we're going to shade below our line. So when we graph this, it's going to look like this. So we see we've got the positive 1 for the y-intercept, and we see that we've got an increasing slope of 2 over 1. So from the 1, it's going up 2 and over 1, rising 2 and over 1. Now let's look at the second inequality. So the type of line that we're looking at here, we've got the greater than symbol here, and there's not a line underneath it. That means it's going to be dashed, and because it's greater, that means that we're shading above the line. So when we graph this, it's going to look like the red inequality that we see up on the screen. So the plus 5, that's our y-intercept, and we have a decreasing slope of negative 2. So it's going down 2 and right 1. It's descending by 2 and over 1 each time. So we're looking now at 4 different regions. We've got a red region, a white region, blue region, and this purplish region. The red region will only contain ordered pairs that are true to the red line only, excluding the numbers that fall on the line. The blue region will only include ordered pairs that make the blue line true, including the numbers on the actual line. But the purple region will be true for both of the inequalities. So no matter what inequality or what ordered pair we pick from, if it's from anywhere in this region, it will satisfy both inequalities. Okay, let's look at another one. This time it's the same inequalities, but we flipped over our symbols here. So in our first equation, the type of line, now we have a dashed line because it's a greater than symbol. And because it's greater than, that means we are shading above. So that's what this is going to look like. Shading above the blue line this time, and it's dashed. And the second inequality, we've got less than or equal to, so this is going to be a solid line. And because it's less than or equal to, that means we are shading below the line. So it's going to look like this. Again, we're using the red and the blue lines here. So looking at this, again, the blue region that we have here will be true for the blue line only, excluding the ordered pairs on the line. The red region down below will be true for the red inequality only, including the numbers on the line. But the purple region, this area right here, will be true for both inequalities. So any ordered pair that is picked from over here will make our inequality true. Now let's apply what we just learned. It takes 2 hours to make the blade of a figure skate. It takes 3 hours to make the blade of a hockey skate. So right off the bat, we can see that we are comparing blades to different ice skates. There is a maximum of 40 hours per week, which means we cannot go past 40 hours. 40 is going to be the greatest. So there's a maximum of 40 hours per week in which the blades can be made for both types of skates. All right, now in the second part here, it says it takes 3 hours to make the boot of a figure skate, and it takes 1 hour to make the boot for a hockey skate. There's a maximum of 20 hours per week in which boots can be made for both types of skates. So we've got blades up here and boots in the second one. And in this next part, we're going to make inequalities that represent each of those. So what is the inequality that represents the time it takes to make the blades of the two different types of skates? So remember we said 40 was the maximum. That means it's going to be the greatest. We can be equal to 40, but we cannot go past the 40. So we've got the 2 hours for the ice skates and the 3 hours for the hockey skates, and these were the blades. And then also another inequality that represents the amount of time it takes to make the boots of the two different skates. So again, we talked about a maximum of 20 hours in the week. So that's going to be the greatest. We cannot go past it. X in both of our inequalities are representing the figure skating blades or the figure skating boot, the whole figure skating system, and then the Y is representing hockey for both of these. So when we go to graph these, let's talk about the graph here. Here's what the graph would look like for the two inequalities. Does it make sense for us to have negative hours for the boots and the blades? Not really. So we can simplify this a little bit more by just looking at the positive values here. Now we're looking at we got the hockey skates over here on the y-axis, and we've got the figure skates down on the x-axis. And we can see that the area that satisfies both of them will be in this shaded region right here. Since we're talking about application, let's try to look at some test type questions and how we can apply this to our tests. So we've got this inequality, and we're trying to match up the given inequalities, A, B, C, and D, to this equation right here. Now we can very easily graph each one of these in Desmos and be certain of our answer, but if you look at each one of your answer choices, A, B, C, and D, the actual graph is the same. They each have 2x plus 1, and they each have negative 2x plus 5. So we've got a line or an equation that is increasing, and we've got one that is decreasing. And we see that right here. The solid line is decreasing, and the dotted line is increasing. So decreasing has to be solid. Remember our trick that we use. If we see a line, we draw a line. Now this has a decreasing slope, but it's showing a dotted line. So A cannot be our answer. Neither can B. But C and D could very well be our answer because both of their negatives have the less than or equal to symbol. So we've got narrowed down now to C or D. And we know that our positive slope has to be dotted, which is also represented by C and D. So now it comes down to our dotted line. If we look at the shading, we see that the shading is being represented below the line. So below the line is the less than symbol. And between C and D with the 2x plus 1, the only one with the less than symbol is D. D is our answer for our inequalities that match the graph. All right, now we've got another one. Brenda's High School Theater can seat at most 400 people. Adult tickets are $5 and student tickets are $2. The school must make at least $1,000 for the show to go on. Which region represents the possible number of adults and student tickets sold that meet the given conditions? So we see we've got our two inequalities here. We've got the 5x and the 2y, and it must be at least $1,000. So we can earn more than $1,000 for sure, or we can earn equal to $1,000. But The problem is the theater can only hold at most 400 people, so that's the maximum. So when we're looking at this, the area that is true for both of them, let's put up some letters here so we can take a look at the different regions. So we've got 4 regions here. We've got region A, B, C, and D. And the only region that is true for both inequalities is region D. So this can help us to determine which types of combinations can satisfy both of our inequalities. I hope this video was helpful. For more videos, please visit bit.ly/BrandonVids. Thank you very much.